All right, and share my screen. Okay, so in last lecture, we talked about what is programming and why we need programming. Also, I give you a little idea about how the Python programming will be integrated to those data analytics applications and how this would be beneficial to an industrial and system engineer. In today's lecture, I will give you an introduction to the basics of Python language. So the first topic is the program steps and the flow or the program flow. Sorry. I think I made a mistake. Oh yeah, it's correct. Sorry. So actually, you've been seeing this slides in the lecture one. Basically, this figure gives you an illustration about how computer work with the instructions and how user, who is a programmer, will give the instruction to the computer. Basically, the CPU, the central processing unit of a computer, is waiting for instructions, and it requires the programmer to tell it what to do next, right? So, and that is the code you will write. So in that sense, the programming is like you need to always instruct the CPU, the computer, to do something else. I mean, to do something or something else. To understand the programming flow or the procedure, there are some important knowledge you have to understand right now, which is the reserved words. So the reversed words, reserved words are the variable name or identifiers reserved by Python. So it has certain meaning there by the Python language. You cannot use it. Basically, this is the Python system only. And it here shows some example of the reserved words. And we will use these words in the following examples. So here shows I would say, a simplest set of code, right? So we have 3-line code. X, 2 is assigned to X, and then X plus 2 is assigned to X, and then the third line, the value of X is printed. So basically, there are 3 different operations. In the first line, it's an assignment statement, meaning the variable is assigned by a certain value, is assigned to a certain value by the programmer. And the second line is the also assignment statement, but its assignment with expressions means it's not just a constant value. It's an expression. So X plus 2 is an expression, and after this the addition expression is done, the value is assigned to the left-hand side, which is X. And the third line of the code is a print statement. Basically, this code utilizes a function, a built-in function, print, to print out the X. I think you have know what print does, right? During the lab session, you have tried to print certain values. Also, the color code, the different colors give you some idea about the different elements in a set of code. So the orange represents a variable, black means the operator, the light blue is the constant values, and this yellow is a function. So that's how a few Python code work, right? It follows the logic. You have some certain assignment for a variable, and then you do some operation using some expressions or some operations, and then you have you can call other functions to do something else, and that's a whole flow for a Python program. So basically, as you can see from the previous example, so the Python programming is just like a recipe or instruction. You just have a sequence of steps to be done in order specified by the programmer. And in these sequence of steps, there could be some steps which are conditional, meaning only if there are some condition to be satisfied, some set of code will be executed. And on the other hand, if the condition is not satisfied, there will be some code will be skipped. So that's the conditional cases in the program step or program flow. Also, another very useful operation is the repeated code, so meaning there will be a loop or some repeated steps will do some operation several times, and that's also a very common cases in the program flows. Also, sometimes we will store a set of steps to be used over and over as needed several places through the program. You will see the conditional and the repeated cases happened throughout the whole program. And let's look at some example. All right, so we have this sequential step. So it's a straightforward. You have a variable x, and it is assigned to a value 2, and then you do the print because you have your x assigned with assigned value there, right? So you can print it out, and then you could change this the value stored in the variable by do such an operation. Basically, the x plus 2, which will give you, because currently the value starting in x is 2. So currently x is 2. 2 plus 2, which is 4. And then this 4 will be assigned to x again. And after this line, the value starting in x is written to 4. And then you print the x. See, its value, its output is x equals to 4, right? So that's a sequential step in a program. So any questions regarding this? Okay, I think I just want to emphasize one point. So basically that is the third line of code. So basically you have to understand when executing this line, especially looking at the right-hand side, you just look at what is the current value stored in this variable. In this case, it is 2. And once the right-hand side completes all the operation, then that is the value assignment. So whatever the right-hand side is, it will be assigned to this x again. And after execute this assignment, the value of x is changed. So otherwise, it's still the previous value. So that in this case, originally x is 2, and after operation, the whole right-hand side equals to 4, and then this assignment, value assignment, and x is changed to 4. That's the whole process. So you have to understand this. This kind of operation happens a lot, right? So another case is this conditional step. So in the conditional step, basically, there will be some conditions, and the Python compiler will check whether these conditions is satisfied or not. For example, the x is assigned to 5, and then a condition x, if x is smaller than 10, will be checked. In this case, x is 5, so it's not satisfied. Then it goes to one set of code, right? It goes to here. Otherwise, it goes to this print function, and it will print smaller, right? But in this case, it goes to it goes to here, and then again it checks whether x is bigger than 20 or not. If the case happens, it goes to this branch and print the bigger here. But because right now x is 5, so it will go through this branch and print this finish, right? So that's the conditional step, meaning only the condition is satisfied, certain function or certain operation will be executed. So if we look at the code here, right? Basically, you need to use the if statement to check whether certain condition is satisfied or not. And you have this colon that's also a part of the format when you write such a if statement. And basically you have all these conditions, and based on the different cases, the different code set of code will be executed in this case. All right. This conditional step is very useful. Actually, you will see probably it happens like 70, 80% during when you write a certain code, because you will, especially when you let the computer to traverse all the possibilities, because that could be different cases, and you just want for different case there will be different thing happen. Then you need to use this kind of conditional steps or the if statement, some similar thing like this a lot to realize the to process the different situation. All right. Any questions? Okay, let's move on. Then there's a repeated step, meaning there will be something there will be something to be processed many times, and in each of the time there will be a variable which represents the iteration, and this variable will change, and in each of the iteration there will be something to be executed, and once there's some condition or the preset numbers of the iteration is satisfied, then this repeated step will stop, and that's how this works. So if we look at this illustration, so initially we have an arrow, we have a variable n, which is 5, and then we check, okay, if n is larger than 0, because now n is 5, so definitely yes, right? And then we go to here. Then we execute this print function. It will print 5, and then another step is we basically the n minus 1 and then assign to the original n. In this case, n currently is 5, 5 minus 1, which is 4, and assign to n to overwrite the number. So now n becomes 4. And then it will check this condition again, see if n is bigger than 0 or not. Yes, right? And it goes to this these steps again and again until when n equals to 0, right? Because basically you will execute when n equal to 5, 4, 3, 2, 1, and then it turns out n becomes 0, and this condition is not satisfied anymore. It will go to this branch and print out the blast off, and this repeated step is completed. So if we look at the code, so by the way, this is just the illustration, not the actual code. This one is the code, right? Basically, here a while loop is utilized. You can see this is the reserved word while, right? So while n is bigger than 0, then these two line codes will be executed. Otherwise, print this, right? It's basically you need to understand the logic of these codes like this. And so the output will be 5, of course, 4, 3, 2, 1. When n equal to 0, this loop, it will not go to this, go to here and execute these two lines again, but just print this line. And that's the end of this repeated step. So there are multiple ways to have this repeated step. While loop is one, and another commonly used one is the for loop. Actually, it can be basically a while loop can be converted to a for loop, and a for loop can be converted to a while loop. Basically, you just need to choose from them according to your need, right? Sometimes you just think the while loop may be a better fit. The for loop could, in other cases, could be a better choices according to the different cases. I will definitely introduce more about loops because this is also a very commonly used tools used programming flows in the following lectures. All right. Any questions?
Yeah, I have a question about the timing of this program. So if you process like this code, then it's just going to go 5, 4, 3, 2, 1 blast off like all in the same like millisecond. Is that right? Like it's not actually a second countdown. It's just going to repeat it as fast. You know what I mean? It's going to process the code as fast as it can.
Yeah, exactly. Yeah, basically these numbers has nothing to do with time. It's not about time. Yeah, you're right. Okay. It's very fast. Probably for, I mean, even you set n to be like, let me see, 1 million, it takes just 1 second or 2. It's very fast. if you, of course, your computer should have a really good hardware. So, because it didn't do much in the while, inside the while. If there are a lot of things to do, it could be slow, but it just print out the number, so it will be very fast for each of us.
Okay, thank you.
Yeah, if you want to do an actual countdown, it requires other functions. Probably it requires a clock function. Basically, you need to know what is the time, the actual time on your computer, and it will wait until 1 second just pass, and then execute something as you wish. But this one just the numbers, has nothing to do with the time. All right. Okay. Okay. Let's move on. Okay. Okay, again, we come back to this code. Actually, last time I showed you, and it seems complex to you guys, right? But if we check this code from the perspective of different program flow, you will have different understanding. about it. So this color represents the sequential code, and this green color represents the repeated, and this red, a little light red, magenta, I don't know. this color is representing the conditional code and a conditional flow. And when looking at this code, you can immediately figure out, okay, the first line, basically it's an input. It requires an input of a file name. And the second line, open, the file will be opened according to what you input here. And third line, it counts how many words there. And it is, all these lines are executed in a sequential order. So these are all the sequential flow. And for the green colored code, it's a for loop. As I mentioned, there are for loop, there are while loop. In this case, it's a for loop. And plus, it's a nested for loop, meaning in the for loop, there's another for loop, right? It's also, I mean, this nested for loop is also a very commonly used skills during the programming. Sorry. So what it does is, for each line of the basically the whole text of the file is stored in this handle, right? And basically it checks each line of the text and split each the line of the sentence to each of the words. And that's the outer loop. In the inner loop, basically it loops through all the words of in the outer loop, it will loop for all the lines. It first loop scan all the text and find out each of the line. And for each of a line of the words, they split it and store it to probably an array, which called words. And in this array, that's the inner loop. It will count how many times a word appears, right? So that's the two level of the loop. But again, it's a repeated program. And then these two value assignment, they are sequential flow. And then another for loop, right? And inside this for loop, you have a if statement, which is a conditional program, meaning there is some condition need to be satisfied, and only in this case, this two line of code will be executed. So that's the conditional conditional program. And finally, there's another print function there, which is again a sequential program. You can see for almost all the codes in a program can be categorized into one of these three different types, right? And with your experience increase, you will be able to decide what kind of program flow you will choose to satisfy your need when program something. Okay. Any questions here? Okay. And as I mentioned, it's basically this this code will give you will basically go through a file and check what is the most frequently used words for the file. And to achieve this goal, different program flows are utilized. And probably we will do a lab session later, just execute these lines of code in the Jupyter notebook, and you can understand how it works better. All right. Then we have other basic elements here, which are the variables, expressions, and statements, right? So let's check them one by one. The first thing is variable. So what is variable? Any idea in your mind? Come on, just give me some answer, no matter what it is.
So would it be like X, Y, or Z?
Yeah,
Something like-
definitely X, Y, Z are some variables. If you ever done some solving equations, the X, Y, Z, right? These are definitely variables. But I would say the key for a variable is it is supposed to be changed, right? That's the idea of variables. So in contrast, there are some other numbers which are fixed number. We call them constant, right? These are the fixed values, and there are different types. There could be numbers, letters, some words, some text. In the program Python program, it's usually called strings, right? And as long as there are values, fixed values, then they can be called constant, right? A typical constant is the numeric constant, right? Like the 1, 1, 2, 3, 98.6. So the first one is an integer, and this 98.6, it's a float number, right? Or some strings, some text, hello world, right? And but they are all constant. They won't change, and they have the specific and fixed number here. One thing you need to keep in mind is when you want to represent a string constant, basically you have to use either the single quotes or the double quotes, right? In this case, the single quotes are used here. Just keep in mind, this is a requirement from Python, right, to represent a string constants. So these are the constants. As I mentioned, the variables are supposed to be changed. So these are not constant, but these are not variables. These are constants, sorry. But constant could be used to assign values to variables, which happens a lot. Again, we have these reserved words. And these are the node to you when you want to define some variable names. So basically, you cannot define variables with the exact name as these. So try to avoid these reserved words. And usually when you type it, the different color code, for example, when you type it in the Jupyter notebook, if you do not know whether it's a reserved words or not, actually the Jupyter notebook, usually these IDEs will give you a different color and give you the idea, okay, I'm typing a reserved words and it cannot be used as a variable name. Try to avoid these, all right? But typically, X, Y, Z, these are the variable names, right? And for example, here, you have X, which is 12.2, and another variable Y, which is 14. So the definition of a variable in Python is a variable is a named place in the memory where a programmer can store data and later retrieve the data using the variable names. To me, it's more like an address. So you have an address, and this address is associated with a family. And once you want to visit that family, basically you just find their address, right? But the difference is you can change the value stored in the variable, and that is a very important features of variable. So the task to choose the name of variable is programmer's task, right? You have to decide what are the names for the variables. And how to name it actually matters. And I will introduce some rules for variable names later. You can, and I will give you some examples, some good name and some bad name, and why the different name could give you different result or different, whether it's convenient to use or not, all right? And the third, and again, you can change the content, the value stored in that variable in the later statement, which is very convenient, especially when you are talking about some iterative process in the repeated program. You want to change the value in each of the step, and definitely a variable would help. All right. So for this case, original x is assigned to be 12.2 and y is assigned to 14, right? But if you write another line of code and assign 100 to x, what happened? So basically, you are changing the value stored in x from 12.2 to 100. And after this line of code is executed, you have the value in x to be 100. So that's what happens. So this gives you actually a very important information. Just imagine you defined a variable in the beginning of a set of code, and you give the variable some value there, and later in later code, you accidentally reuse this variable. You don't know, it's not supposed to use it, but you accidentally use it and change the value to be something else. And it turns out you change the value on that variable and you are still using it, it could cause biggest problems. It causes really dangerous problems. So manage the variable, name it in a good way, and do not have, I won't say do not, but has as minimal as possible global variable is the rules you have to follow. Global variable means if once you defined somewhere, it will always work in the later code. So just in case you accidentally change the number in the variable, it could cause problem. And you might say, okay, it's not a big deal, right? Just some numbers. But do you know which company has the most line of code? Just give some guess. Anyone have idea?
Google.
Okay, Google. We have one candidate. And what else? In your mind?
Microsoft.
Pardon?
Microsoft.
Okay, Microsoft. Okay, good. Anything else?
Or
Apple.
actually, Apple, because
okay.
they're really inefficient.
What was that?
I said Apple because they're very inefficient.
Come on. Okay. Okay, we have Google, Microsoft, Apple, probably someone will see Amazon, Qualcomm, whatever, right? But let me tell you, there's none of them have the most code. And the one who has the most code is Lockheed Martin, who is producing the weapons, who is working in the defense industry. Just imagine there's some advanced missile, nuclear missile, or some jet. And on their computer, there's a global variable, which will determine if there's a missile launch or not. And some engineer just made a mistake. Okay, that engineer changed the value by accident. And it turns out it will lead some really terrible tragedy. It could, right? Because if that variable is associated with some critical task and you do not know it, you change it, that could be very, I would say, serious problems, right? Actually, I was surprised when I heard from, when I found this result by Google, by searching online. So Lockheed Martin actually has the most code among all the companies. Well, okay, good. So that's the variable and variable names. I will introduce more about the naming of the variables. So there's some rules. Definitely there are something you have to follow. For example, these variables must start with letters or underscores, right? And cannot start with really some special some special characters, right? Must start with letter or this underscore. Also, it must consist of letter, number, and underscores. No other special characters. Also, it's case sensitive, meaning a capital A and up letter A, then uppercase A, they're not the same. So that's another thing you have to keep in mind. I remember one student in the lab session, basically there's a mistake made because of case, right? Case sensitivity is not followed. So you define some a variable with upper with all upper cases, but you call it, you type it using the capital, and it doesn't work, right? So the case is sensitive. That's a very important thing you have to keep in mind. So there are some examples showing here. And there are some good ones which will make sense to you. It gives you a lot of information. Basically, by just looking at the name, you will have some guess about what this variable is about, right? For example, spam, X, or speed, something like these. But if you have these ones, well, the compiler will give you error. Basically, you cannot use them. You cannot start a variable using numbers or some hashtag or include some dot in it. So these are not allowed. And again, this case sensitivity should be followed as well. If you define a spam in all capital letters, then try to use it, by typing all the capital letters later, okay? Otherwise, there will be some error. Or you just misuse some other variables defined somewhere else. All right. Although satisfying these basic rules are simple, but still there could be some difference if you choose different names. So there's another very important rules you want to follow. That is, basically you want to name the variables which will help you to memorize them. And that is very important as well, especially when you are maintaining a very big project. You have many codes, many files, and when you try to retrieve one variable and check the variable, especially when there's something wrong and you want to go through the whole code, it's better to have your variable name to be easy to memorize, as well as if the variable name will make some sense to you, will give you some information, that will also save you a lot of time, right? Sometimes those well-named variables are often sound too good to be believed to not a keywords. But if you check the color code, the color of a variable defined by the programmer and the one which are the reserved keywords, they are in different colors. In the those IDEs in these compilers, so you will know. All right, we have an example. So basically, we define this XYQ3Z90CD variable, which is perfectly fine. I mean, which is fine, not perfect. It follows all the rules, so there's no problem to define it. And you have this variable, and you assign 25.0 to this variable, and another variable X1Q3Z9AFD is assigned to be 12.50, and then another in the third line a multiplication has been done, and turns out a print function is executed. So just tell me, what does this code do? Any idea?
Is it just multiplying the two variables, the first two variables, and then printing the last variable?
Yes, exactly. So you're right, but it takes a little while to look at it, look at it clearly and understand what it does, right? So how about we have something like this? We define a variable A, which is 25, a B, 12.5, and a C, which is the multiplication of A and B, and then you print C. So basically, by looking at this, it takes you like probably one second to understand it. So you can see, if you have a really easy to memorize name, it makes things such simpler, right? Much more simpler. But the thing is, what does A mean? You don't know, just some number. You have no idea what A could be, B could be, or C could be. So if we name this variable to be hours, rate, and pay, then it's as same as it's as same as this ABC in terms of the easy to memorize, right? It's also easy to memorize, easy to understand, but at the same time, it gives you more information, right? Means actually you are calculating a pay by knowing the total number and the rate per hour. The total hour and the rate per hour, right? Then you have a pay calculated. So this is actually the most preferable way to name your variables. Easy to memorize and providing information to the programmer. I mean, just imagine you're working in a group, and you do some part, and someone else do some part, and you want to, and the third people will combine what you two did together in a big project. So basically, the third person will check the code you defined and the other people does. And if the name is so hard to memorize and understand, it will really painful. So that's for the collaboration, right? You have to make the collaboration as easy as possible. I mean, sometimes even for yourself, if you write some code a long time ago and you do not name it in a good way, you could totally forget anything. And when you retrieve your old code and do something else, it will take you much more time, right? So try to understand this, these rules and also the suggestions when you name your variables. All right. Any questions so far? Okay. No. Good. Let's move on. Go ahead. So again, we have this these sentences of the lines, and you can see the value assignment by constant or some expression and some other functions which takes variables, right? So if we check this line of code, so basically it does something which is more complex than the previous ones. Basically, the right-hand side is an expression, and it has multiple operations. So what the right-hand side does, and what should you execute the different operations? You can see some operators showing here. These are star signs, and also you have parentheses. It might suggest some orders when you're operating on the right-hand side code. So what are these? Let's check them one by one. So in this specific case, what it does, so basically if you have the x has an initial value 0.6, and then in this line of code, for the right-hand side, the x is still 0.6, right? Basically, you just, the Python compiler will substitute the 0.6 to the right-hand side, and it will do the operations in certain order. So the code, this expression in the parentheses will have the highest priority. So 1 minus 0.6, it's 0.4. And then you have 3.9 and another 0.6 and another 0.4. So this star operator means the multiplication. So you just multiplied 3.9, 0.6 and 0.4 together, and turn out you have this 0.936. And that's the overall result of the right-hand side. And you have this assignment statement. And this 0.936 is assigned to the x. And now x is 0.936. All right? So here gives you the idea. And after this, the execution of this line of code, you will have the x to be the new number over here. And through this process, you can see the different operations. Apparently, the star sign, operator is the multiplication, and the parentheses will give you the different orders when you do the operations. So then let's talk about the expressions and talk about the orders in these expressions. So as I mentioned, there are different operators, including there's a star, which is multiplication, and we have the addition, we have subtraction, multiplication, division, and this two star together means a power. And this percentage means the remainder, right? And I will show you some examples for some of the operations, especially the power and the remainder, because they are not that obvious than the previous than these some addition, subtraction, multiplication, and division, right? So let's look at them one by one. So we have a set of code. So basically, this is the addition, multiplication, and division, right? These are simple. And then we have another variable JJ which is 23, and KK equals to JJ, and this are percentage 5. What does it mean? Meaning JJ, what is JJ? Basically, JJ will be divided by 5, and you just figure out what is the remainder for this division, and assign this remainder to the new variable Kiki. So that's what it happened. Basically, it does this division here and figure out this remainder. All right, and then we have 4 powered by 3, means 4 is powered by 3. So in this case, then it's a 3, 4 multiplied together, right? So it turns out to give you 64. So these are the how you should use these two remainder and power operation. So any questions? Okay. So basically, these are the one you need to memorize when you write your code. But another thing is the order, right? I think it happens when you learn the different expressions, different operations in your high schools and middle schools. There are rules for the order for different operation. Similarly, in the Python programming, there are orders. So for example, you have this line of code, 1 plus 2 multiplied by 3 minus 4 over 5 powered by 6. So which one should be the first, right? So there are certain rules for this order of the operation. First of all, the parenthesis always respected, means it has the highest priority, right? And later is the exponential, the power, right? And the multiplication, division, remainder. And then we have the addition and the subtraction. If they are in the same level, if some operations are basically they have the same priority, you just follow the left to right order, right? That's it. So it's very similar to what we learned in the high school math. And let's look at some example. All right, we have x is assigned the right-hand side value, which is an expression. So what it does is first find whether there are parentheses or not. In this case, there's no parentheses. Then whether there is exponential. Yes, right? 2 powered by 3. So 2 powered by 3 should be calculated first. And you have 8, right? 2 powered by 3 equals to 8. And then how about other operations? Multiplication and also division in this case. If there's a remainder, they are in the same level. So we have multiplication, division, and addition. So addition is in the lower level. So we first do the division and multiplication. And for division and multiplication, they are in the same level, but follows from left to right order. So 8 over 4, which is 2, and multiplied by 5, which is 10. And turns out you have 1 plus 10, which is 11. So that's the whole procedure you compute this expression. And it turns out this 11 is assigned to x. And if you print out x, it is 11 currently. All right. So for this part, any questions?
Yeah, I have a question. So
sure.
you're denoting power with 2 multiplication signs. Is that typical in programming?
No, actually, no. In different language, it has different denotation. I mean notation. Sorry. For example, I don't know whether you used MATLAB. In MATLAB, is a different. It's a different sign. Let me draw it. It's if you want to write 2 power by 3, it's something like. Right. That's what the power is represented in MATLAB, and in Python is something like this. In some language there is no power. You have to use function. Means there are some function which will give you you need to input the parameter like this, something like this. So it's not a commonly used expression. You have to look at it when you learn a new language.
So but for Python, is it going to be 2 multiplication signs?
Yeah.
Okay, and then for square root, would you use 2 divisions?
For square root, I'm not sure about it, but I think it's I didn't check whether the square root is in division. I don't think it's a division. I will give you a more comprehensive table of all the operations. Here, just list out the commonly used one, but definitely I will give you a list. I mean, you don't have to. I mean, when you have experience, you might memorize them, but in the very beginning, you can just look up the table and see which one you should use.
All right, thank you.
Yep. So I just want to put more words. So basically, when you learn one language and understand the concept of programming, then you will figure out actually learning other programming language becomes so easy because although the format, the grammar or these signs could be different, but all the basic concept and logic are the same. The only thing is you just check this alpha, beta, check these operation table and practice by yourself, and probably 1 week, 2 weeks, you get used to it, and then you pick up another new language. But from the very beginning, it takes, if you have no knowledge about any programming language, that could be a challenge, all right? Okay, let's move on. Let me see, how can I, okay, good. So there are little tips, tips for you as well. When you deal with the operations, basically follow these rules. Also, when you write the code, be aware of the parentheses, and especially if you want to have some lower priority operation to be the higher one, definitely put them into the parentheses. And also keep the mathematical expression to be simple. And because that's, again, for your own benefit, especially when there's something wrong, you definitely want to check it. And you definitely want to check it. I mean, if you write it very simple, it's much easier to check, right? And also, if there are long sequences, long series of mathematical operation, try to break them down, which will make more sense to you when you check them, or debug if there's something wrong. All right. Just like when you write a long sentence, it's hard to follow. Break down it to several sentences. Same thing. So another concept in Python for the variables, literals, or constants, it's the type. Means it's these variables or literals, these representations have different groups. For example, I mentioned the integers, and also I mentioned float number and also the strings. So these are different types. So a good thing for Python is Python knows the difference between different types. And you do not need to specify the types when you define a variable or write a constant. Python will detect it and assign the type to that thing automatically instead of letting you to assign it. So that is very convenient for the programmer. Why I mentioned this, because I used to program using C++, and C language for a long time. In C++ and C, you have to specify the type yourself. The programmer will take care of the type, which is painful. And that could cause problem because if you accidentally do something, for example, you just do some operation to some variable in a wrong type, it could give you totally different result. But in Python, the good thing is the Python does the job for you. It will differentiate the different types. But still, you have to be aware when you write some code, and I will show you later. So a good thing for the type is, for example, if you have a plus operator, usually it means addition. If you use this operator between two integer or two float numbers. But this plus operator can be also used for the string variables or constant. For example, if you look at this line, this line of code. So you have a constant hello, which is a string, and another constant there, another string, and you use plus in between. So what happened? Basically, you are stitching the two strings together to form a new string, which is hello there. Okay, it's not just hello, it's hello space. See, there's a space. And there. So you will stitch this hello space with there. And it turns out, start the result to a new string, a new variable EEE. And if you print this variable out, you will see hello space there. So that will do, basically Python detect, okay, these two constants are in the string type. And if you use plus between the two, that means, okay, you are not actually doing a plus for a number, but you are doing the stitching operation for two strings. So that, which is really good. But you have to be careful still, especially if you do some mistake, if you have some mistake. For example, you have this EEE, which is the result of this stitching, hello space, and there, but you accidentally do another addition with an integer number, EEE plus 1. So what happened? Basically, this EEE is a string, and 1 is an integer. So there's no possibility for an integer number to get to be added to a string number. It turns out there will be some error displayed. You cannot do it. So still, you need to pay attention to your code when you use some operators. All right. So in Python, there's a function called type. So this function will take certain constant, certain value, certain variables as an input, and give you what type of that number is. So for example, in this case, if you put EEE to this function, and it will return string, str means it's a string variable, it's a string type. And if you input 1 there, and it will return this integer type, right? So that if you have some bug, for example, you have this error and have no idea what happened, you could use a type to see whether you mistakenly put two types which are not supposed to be put there, and that this type function could help you. Also, even for the numbers, there could be different types. There are integers, there are floating numbers, right? So for the floating number, usually there's a decimal part, like these ones. Also, there are other types, the other number types, which are the variations of float and the integers. So here shows some examples. You have integer here and another float number, and so on and so forth. So can we make conversion between two different types? The answer is yes. For some cases, it's yes, right? For example, you have an integer and a float number in an expression. If you do not do anything, then the integer number will implicitly convert it to a float. For example, in this line of code, you have a float number 99, and you have an integer number 100, and you want to print out the addition, the result of addition of the two, and the Python, what Python does is first convert this 100, the integer, to be a float number, and do the multiplication and print it out. And it turns out it gives you this, right? And similarly, you can use a type to see what happened. For example, the I, which is 42, type inputted to the type, and it's a integer number. And if you have if you use this float, see, you use the float and then a parenthesis, and it puts the original integer number 42 here. Basically, this line of code convert an integer number I to a float number and assigns the converted result to a variable f. And if you print f out, it is 42, which is a float number. You can do this vice versa, means you can use the integer, you can use the integer, I mean, int, not integer, int and parentheses, and put f inside, right? And then it will convert the f, the original f, which is 42.02, an integer number, which is 42. You can try this yourself, all right? But here gives you two different cases. One, an implicit conversion by Python automatically, or a explicit conversion by yourself. You just call the int or float function to do the conversion. All right, any question? Okay, I think I will stop here, and I will upload this lecture notes to my courses, and you can check them. In the next lab session, we will practice some examples about the variables and expressions using the Jupyter Notebook and in the Anaconda framework. All right.
Could you go over one more time what exactly float does? Like, what is float?
Oh, float. You mean the float type, right?
Yeah.
The float type means the number has the decimal parts. It's the so-called floating point numbers, which is the represents the most of the number in computer. Basically, if something like this one, negative 2.5, 98.6, these are the floating number.
Okay, got it.
So a floating number is just any number that's not an integer?
You can understand like this. Yeah. Yeah, you could understand this. These are the most widely used ones. Yep.
All right. Thank you, Professor.
Mhm.
We'll see you Tuesday.
Okay, see you guys.
Thank you.